Welcome back. In our last explainer, we covered the absolute essentials of cloud databases. Today, we're going to level up and answer the big question. With so many options out there, how do you pick the right one? It can feel pretty overwhelming, right? And picking the wrong database can lead to some serious headaches, performance bottlenecks, budgets getting blown out of the water, you name it. But don't worry, by the end of this, you're going to have a clear mental model to navigate these choices with confidence. Okay, let's dive into this. So, here's our game plan. We're going to look at a series of common, high-stakes challenges, and for each one, we'll find the perfect database champion for the job.
All right, let's kick things off with a scenario that is all about just mind-boggling scale.
Okay, so picture this. This is a classic big data problem. You've got a massive, constant stream of incoming data, what we call time series data. Every single second, 50,000 new data points are flooding in. You're not just storing data here, you are literally drinking from a fire hose, and you need to be able to analyze it fast.
For this kind of heavy-duty industrial-scale workload, our champion is Cloud Bigtable.
So, what is it? It's what's known as a NoSQL wide column store. Now, that sounds complex, but let's break it down. NoSQL just means it doesn't use the traditional rows and column structure you might be used to. And wide column means it's super flexible. It's built from the ground up for exactly this kind of write-heavy analytical job. It's all about raw performance at a massive scale.
Okay, but here's the catch. This leads to a really critical performance issue that you absolutely have to understand when you're working with Bigtable. It's a common trap that a lot of people fall into.
So the whole thing comes down to how you design your row key. That's the unique ID for each row of data. If your row keys are sequential, maybe because you're starting them all with a timestamp, then all your new data tries to hit the exact same server node at the same time. Imagine a 10-lane highway suddenly funneling into a single toll booth. That's a hotspot, and it will kill your performance.
And this slide just lays out the solution perfectly. Instead of leading with that sequential timestamp, you start with something that's much more varied and random, like the sensor ID. That one simple change is a total game changer. It distributes all those write operations across all your servers, like opening up all the toll booths at once. Problem solved. No more traffic jam.
Okay, let's switch gears. We're moving from massive scale to our next scenario where the stakes aren't just about size, but about being absolutely perfectly correct everywhere, all the time. Right, so for a system like a bank, eventual consistency, which is a fancy way of saying the data will all match up, eventually, is a complete non-starter. You can't have that. You need every single transaction to be perfect, accurate, and visible everywhere on the globe, instantly. We call this ACID compliance, and it's basically a guarantee your data will never be in some weird, incorrect state.
This is the exact problem Cloud Spanner was built from the ground up to solve. It's a truly unique beast in the database world. There's nothing else quite like it.
Spanner gives you the best of both worlds. You get the mind-blowing scalability you'd expect from a NoSQL database, but, and this is the magic part, you also get the strict, rock-solid consistency and relational structure of a traditional database. It's all of that, designed to work flawlessly across the entire planet.
Now, what about the vast majority of applications out there? You know, the ones that rely on those traditional relational databases we all know, like MySQL or PostgreSQL?
So this is a super common requirement for disaster recovery. We're not just talking about one server crashing. We're talking about an entire geographic data center region going offline. You can't afford to be down for hours. You need a plan to get back up, and fast. For this, our champion is Cloud SQL. It's the reliable Office filing cabinet. It's Google's fully managed service for MySQL, PostgreSQL, and SQL Server. It handles all that familiar structured data that powers countless websites and applications. And its superpower for this scenario is the cross-region read replica. This setup lets you fail over to a completely different geographical region, getting your application back online in minutes. Now, it's really important to get this right. This is for disaster recovery. It's different from high availability, which protects you from a smaller failure, like a single zone going down within a region. So Cloud SQL is fantastic for that structured data. But what if your data isn't so neat and tidy? What about modern mobile apps where you need to work offline and the data structure changes all the time? For that, we have a different champion, Firestar. It's a document database, so it's way more flexible. Think of it less like a rigid filing cabinet and more like a collection of smart, self-syncing notebooks. Okay, let's look at one final scenario.
This is for those times when the only thing that matters is pure, unadulterated speed. In this case, even a really fast database just isn't fast enough. Any lag you can perceive would totally ruin the experience for the players. You need in-memory speed to deliver that truly real-time feeling. And for that, we have Memory Store. It's a managed in-memory data store. Because all the data lives in RAM, not on a disk, access is incredibly fast. It is perfect for caching and for use cases just like this leaderboard, where your response time is measured in microseconds.
So, we've walked through a whole range of different problems and found the right database champion for each one. Let's bring it all together.
Honestly, this slide is your cheat sheet. And what's really important here is how it frames the choice. It's not about which database is the best overall. It's about which one has the right superpower for the specific challenge you're facing. Are you building a warehouse for petabytes of data, or do you just need a sticky note for lightning-fast access?
And that's the big takeaway here. Always start with the problem, not the product. Ask yourself, is my primary concern massive scale? Is it global consistency? Is it a traditional, familiar structure, or is it pure sub-millisecond speed? Answering that question first will lead you directly to your data champion.